Okay, everyone. What we're going to be covering today is simplifying rational expressions. So it's kind of like reducing fractions. We're going to be going over simplifying, multiplying, and dividing rational expressions. So the very first thing that I give you on your notes you should have in front of you right now, I give you a rational expression, and it's x squared minus 4x minus 32 over x squared minus 16 equals, and then I give you another rational expression, and I say x minus 8 over x minus 4. Now, these two rational expressions are equal to each other, and I'm going to explain to you today how this is equal to this. Since this is a STEM class, I'm sure most of you can kind of fill in the spaces of how you think it's equal. But in the notes I say, look, let's plug a 2 into this equation. Because technically or conceptually, this represents a number. This number divided by this number is going to give you the exact same number if you were to take this, because this is an expression, this number divided by this number. So once we simplify this, the way we simplify this to get it to equal this is we have to factor this. So we have x minus 8 times x plus 4 over, this is a difference of squares, so this would be x plus 4, x minus 4. Now look, whenever you have a rational expression factored, you can always cancel up and down or vertically if there's another expression, but there isn't another expression right here. So what I'm going to do is I can cancel x plus 4 times x plus 4. Technically, if I plug a number into x, these two are the exact same number, so conceptually I can get rid of those, giving me x minus 8 over x minus 4. You see how this turns into this. So this is my answer, x minus 8 over x minus 4. But that's not what I wanted to show you right now. I wanted to show you that when you simplify this over into this, let's plug a number in. Let's plug a 2 in. Let's say in this rational expression and this rational expression, let's just say x equals 2. So watch what happens when I plug a 2 into here. Plug a 2 into every single thing. Watch. 2 squared is 4 minus 4 times 2 is 8 minus 32 over 2 squared is 4 minus 16. Now I'm going to plug a 2 into here also, and I'm going to get 2 minus 8 over 2 minus 4. 2 minus 8 is equal to negative 4 over negative 2. Now when I clean this up, watch what happens when I clean it up. I have 4 minus 8, which is negative 4. Negative 4, negative 32 is negative 36. And 4 minus 16 is going to give, 4 minus 16 is going to give me negative 12. I'm sorry, this is a negative 6. 2 minus 8 is not negative 4, it's negative 6. So look, negative 36 divided by negative 12, which is positive 3, is the exact same thing as negative 6 divided by negative 2, which is equal to 3. You see how once you plug a number into the x, everything works out. But you're not going to be plugging a number into any x. All it's going to ask you to do is simplify the expression. So we're going to do some examples right now before we go on to multiplying and dividing. So on the next thing on your notes, I give you another example question. This one is just with exponents. So I have 6x to the 4th squared. So 6 squared is 36. X to the 4th squared is x to the 8th. 36x to the 8th over 12x. Okay, in the situation like this, you're going to have a couple questions where it's going to ask you to simplify just exponents, where you don't have a rational expression you don't have a polynomial on top or on bottom, like plus or minus something. Anyways, I can get rid of 1x here, giving me 7x's on top, and 36 divided by 12 is 3. Super simple. That one's a really, really easy one. The next one is a squared plus 5a plus 4 over a squared plus 9a plus 20. Okay. Now, if you were to plug a number into your a, which you do not have to do, but if you were asked to plug a number into your a, and once again, these questions that I'm doing are the practice questions on your notes. So if you were to plug a number into a here and an a into here, and you simplify your answer, you're going to get what we're going to simplify it to. Might sound kind of a little strange. Let me explain it. First off, the very first thing you have to do is factor. You have to factor the top. This is going to give me a plus 1 times a plus 4. Because 4 times 1 is 4. 4 plus 1 is 5. That's your numerator. Over, factor the bottom. Two numbers that multiply together give you 20. Add together to give you 9. A plus 5, a plus 4. Please understand, you don't have to say 5 and 4. You could say a plus 4 and then a plus 5. You could say a plus 4, a plus 1. It doesn't have to be in that specific order, but the way it's factored, it has to be in that order. Okay, and then anyways, these two cancel out. The reason why is if I plug a number in for a, let's say I plug a 1 in for a. This is going to give me 1 plus 1. This is going to give me 1 plus 5. This is going to give me 1 plus 4 and 1 plus 4, which is 5 over 5. 5 over 5 cancels out. So conceptually, whenever you have a binomial or something divided by the same thing on top and on bottom, they cancel out. So the answer for this, a plus 4 over a plus 4 cancels out. And this gives me my answer. My answer is a plus 1 over a plus 5. Now, when you're doing these, and if you're like, I don't know if I did this right, just plug a number in for a, or for whatever variable is, to see if you get this to give you the same thing as this. And the easiest number to plug in is a 1. So whenever you're having a hard time figuring out if you're doing it correctly, always plug in a equals 1 or x equals 1, whatever your variable is, and then simplify. Look, a squared is 1. 1 squared is 1. 5 times 1 is 5. A squared is 1. 9 times 1 is 1. So look, 5 plus 1 is 6 plus 4 equals 10. This is 10 plus 20 equals 30. This is going to reduce to 1/3. If I plug a 1 into here and a 1 into here, this is going to give me 2 over 6, which is equal to, boom, 1/3. Same thing. So whenever in doubt, as you're going to see, we're going to do a couple more that are a little more in depth. Plug a 1 into the variable after you get the simplified answer and see that if that answer is the same exact answer as your original one simplified. Okay. Or just don't get it wrong, and you won't have to do that. All right, the next example is this right here. Go ahead and pause the video, because you should be able to do this pretty simple. Pause the video and see if you can simplify this. Okay, so if you paused the video, you should have been able to see that this is really simple. This is going to give me... Sorry, my dog's out here as I'm doing this. This is going to give me n plus 5 times n plus 1. These two simplify, giving me n plus 5 as my final answer. Okay, so now what I want to show you on the next thing of notes is whenever I tell you, whenever you are multiplying or dividing, I'm going to show you in a second, you can always cancel top and bottom and diagonally. What you can never do is cancel left and right. You can never cancel your numerators or your denominators. You have to simplify first. That's why I wrote that in red in the notes. You need to simplify before you cancel anything. So look, here we have 2, the next example, 2 over v squared minus 12v plus 27 times v squared minus 81 over 4. Now, I don't think I'll have this problem in the STEM class, but normally when I have Im3, some students will do this. Some students will say, okay, 2 goes in the 12, so I can cancel out 2 and a 12 to give me 1 and a negative 6. That's incorrect. You cannot just start canceling chunks of it without doing it to the whole thing. If 2 went into all 3 of these, yes, you could do that, but you can't just divide it into one specific thing. Okay, before I do anything, I have to factor. I'm not going to worry about that it's this rational expression times this rational expression. I'm just going to factor everything. I can factor 2 numbers that multiply together to get 27, add together to get negative 12 is negative 3 and negative 9. I can factor this. This is v plus and v minus 9, because this is a difference of squares, over 4. And now what I told you in the notes is you can cross cancel diagonally. So watch this. I can't do anything with the v minus 3 and v plus 9, but I can cancel out. These are the same. So you're always going to cancel out when they're the same. Whenever you have numbers, 2 and a 4 reduced to a 1 and a 2. So my final answer for this rational expression, or the product of these rational expressions, is I have 1 over v minus 3 times v plus 9 over 2. Now the very last step is you can't cancel anything else diagonally, so you multiply. 1 times v plus 9 is v plus 9 over 2 times v minus 3. You can leave it like this, or I don't know, it depends on what the worksheet's answers are or what the test answers are. V plus 9 over 2 times v minus 3 is the same thing as 2 times v and 2 times negative 3. These two are equivalent. I don't care how you do it, but they're both the same. Okay, now we're going to get into a couple more difficult ones. If you remember with dividing fractions, once again, this is a STEM class, so I think most of you guys will remember. The next example question, see if you can do this on your own. I'll write it up here, x squared minus 16 over 9 minus x divided by x squared plus 14x plus 40 over x squared plus x minus 90. Pause the video, see if you can do this, but remember that trick with dividing fractions and see if you can do it. Okay, now before I do anything, so you should have already tried it, before I do anything, I'm going to factor. But before I factor, remember how you divide fractions? You change this to a multiplication. Dividing fractions is multiplying by the reciprocal. So when you divide, you're going to multiply by the reciprocal. I'll do that in a second. I'm going to factor everything first. X squared minus 16 is x plus 4 and x minus 4. And I just cancel it out just so I know what else I have to do. Okay, now look, 9 minus x, I know, and you guys are a STEM class, so you should understand also, you're not going to get a 9 minus x in here. But if I did this, if I did negative 1 times This negative 1 times 9 minus x is the same thing, or I'm sorry, 9 minus x is the same thing as x plus 9 times negative 1, because negative 1 times x is negative x. X minus 9. Negative 1 times x is negative x. Negative 1 times negative 9 is a positive 9. So this and this are the exact same thing, and you're going to see why I did this in a second. Okay, now times, the reciprocal. So I'm going to mentally flip this and put this on top, and then factor this. Two numbers that multiply together to get negative 90, add together to get negative 1 is negative 10, positive 9. And then this, because I'm dividing, I'm multiplying by the boop reciprocal. So this is my denominator now. Two numbers that multiply together to get positive 40, add together to get a positive 14 is going to be positive, I'm having a brain fart here, 10 and 4. X plus 10, x plus 4. All right, now I have everything ready to factor. I'm sorry, everything ready to simplify. I've simplified it first, meaning factored. Now I'm going to cross cancel. Look. Oh, this is going to be, sorry. This, there's one thing that I did wrong. This is a positive 10, and this is a negative 9, because 10 times negative 9 is negative 90. 10 minus 9 is a positive 1. That's a plus. Boop. All right, now watch. I can cross cancel. I can go x plus 4, boop, x plus 4. I would reduce top and bottom right here. Look, x plus 10, boom, boom, those are gone. X minus 9, boom, boom, those are gone. So my answer is everything's canceled out here. These two are canceled, or this, everything is canceled except for x minus 4 divided by negative 1, which gives me an answer of negative x plus 4. So if you, this is your answer. If you plugged in the same number into every one of these x's, you would get the exact same answer if you were to simplify it to this and plug a number in for your x. Okay? Now I have the last two questions are kind of weird looking, but I promise you they're not weird. It just looks weird. And in math, they love to give you strange looking questions, but when you simplify them, or when you work them out, it's all the same concept. So look, I'm going to draw this. See how it says 1, or not draw this, but write this. 1 over 5p squared. Look, 1 over 5p squared, then I say divided by, and I have this big thing. 1 over 5p squared divided by, I'm not going to write that fraction because a fraction is just, it's division. I'm going to rewrite it like this. 1 over 5p squared divided by 9p minus 36 over 5p to the third minus 35p squared. This is way easier to look at now. Because normally, in the question that I gave you 1 over 5p squared divided by 9p minus 36 over 5p to the third minus 35p squared. And this was the question right here. But 1 over 5p squared, this is divided by this rational expression. Boom. Now that it's set up like this, I can start simplifying everything, making it super, super easy. Okay, look. First off, I can't reduce anything here, so I'm just going to leave this 1 over 5p squared. This is division. So division is the same thing as multiplying by the reciprocal. So this is going to be multiplied by, I'm going to factor out, because this is going to be my numerator now, I'm going to factor out a 5p squared from both of these, giving me p minus 7. 5p squared times p is 5p to the third. 5p squared times negative 7 is negative 35p squared. Now I'm going to factor out a 9 from this, giving me p minus 4. Now here's my new expression. Now it looks like the only thing that I can get rid of is this here and this here. There's a 1 here, so I don't need to do anything with this. And my answer is just, if I clean all this up, I have p minus 7 over 9 times p minus 4. Okay, I'm going to have you guys look at the last question right now. Pause the video and see if you can answer the very last question. Go ahead and give it a shot. All right, I'm going to do this one a little faster. You should have paused it, see if you got the answer that I'm going to do right now. 1 over n plus 9 divided by 6 minus n over 3n minus 18. But I'm going to change it to multiplied by the reciprocal, 3n minus 18 over 6 minus n. The reason why I'm doing this is because this is divided by, but I'm changing it to multiplying by the reciprocal. Now look, see how you have 6 minus n? I'm going to change this right off the bat. I'm going to change this to negative 1 times n plus 6. Because negative 1 times n is negative n. Negative 1 times n minus 6. Negative 1 times n is negative n. Negative 1 times negative 6 is positive 6. And I know this is more likely to come up in a factor than a negative variable first. All right, now let's factor this. 3n minus 18, I can factor out a 3, giving me n minus 6. 3 times n is 3n, 3 times negative 6 is negative 18. Okay, and now I'm ready to go. I'm going to clean this up and write this over here, and I can't really do anything here. I can reduce technically these ones, but whatever, who cares? I can't do anything here, but what I can do is this. These cancel out, n minus 6 and n minus 6, so I have 3 and a negative 1 left. Now 1 times 3 is 3 over negative 1 times n plus 9. Or I could write it as negative n minus 9 or 9 minus m, or negative 9 minus n. A really easy error that people do is they'll reduce the 3 and the 9. You cannot do that unless you can reduce this 3 into everything in here. This is your answer.